Hello, everyone. We will be starting the webinar in just a quick second here. We're going to let a few more attendees trickle in. Okay, it looks like we've got most people. So I'm going to begin by sharing my screen and beginning the webinar. There we go. Okay, so welcome to our webinar, Instant Processing and More, hosted by MicaSense and Pix4D. Today we're going to be discussing Pix4Dfields, a new product from Pix4D, and the RedEdge multispectral camera from MicaSense. We'll be talking about how these two products can help you gain in-field insights. My name is Alyssa Ryan, and I'm going to be your moderator for the next hour. I'm the Marketing and PR Manager at MicaSense. I'm joined by Robert Parker. He is the Customer and Support and Training Manager at MicaSense. He's been with the company for about 2 years and has about a decade of experience in GIS and remote sensing. He contributes to all areas of the company, from marketing and sales to technical integrations and software development. We're also joined by Jorge Fernandez from Pix4D. He's located in the Pix4D Berlin office and is the Agricultural Solutions Manager. He has experience in the geospatial, drone, and agricultural industries and has a deep understanding of the ag tech market needs. He's responsible for Pix4D's strategic partnerships and for product business development strategies for the agricultural industry. So welcome, Robert and Jorge. It's very nice to have you both here.
Thanks, good to be here.
Great.
Thank you, Alyssa.
Yes. So before we begin, I want to go through a brief agenda of what we'll be discussing. We're going to start by giving an introduction to both RedEdge-M and Pix4Dfields, and then we'll be taking a deeper dive into Pix4Dfields through a live demo, going over features and capabilities. Then we'll be discussing a user experience of both RedEdge and Pix4Dfields and giving more detail as to how that user was able to leverage both products. Then we'll open it up for discussion and audience questions at the end. So thank you for being here. We really appreciate your time, and we hope to help you get some really good information in the next hour. So we're going to start with a poll question. You should see a pop-up on your screen in just a second here. The question is, what best describes your role? You're either a grower, a service provider, or a researcher and an educator. You could also be a drone integrator or something else. So please fill in your answer, and we can kind of cater our discussion and some of the content to this audience. Okay, so I'm going to give you another few seconds, and then I'm going to close the poll. Looks like we've got most of our answers in. Great. And then I'm also going to share our results. Looks like, from what I'm seeing on my screen, the majority of you are researchers and educators or service providers at 33%. And then we do have a small bit of integrators, growers, and other. So that's great. Thank you so much for being here. And we'll, like I said, we'll try and cater our discussion and questions to those groups. Okay, so now I'm going to turn it over to Robert to discuss RedEdge-M.
Thank you very much. RedEdge-M is the latest evolution of our RedEdge product line, and I'm happy to talk to you about it today. So the basic thing you need to know about RedEdge-M is that it is a 5-band multispectral sensor. So the 5 bands are red, green, blue, so you get an RGB, a visual image, but as well there's also The invisible light, we have near infrared as well as something we call red edge, which is just past the red wavelength into invisible light that we can't see. So we call it red edge. And with all of that, you can generate very valuable vegetation index layers. You can get the visible RGB image and other composites as well, just from one flight. So you can fly once and have all of these different layers and calculations and things that you can do on the data just from one flight. Another aspect of RedEdge-M data is that you have full access to the raw data. With this sensor, you are not locked into any one particular plan or subscription model or something like that. You have freedom of choice. You can go anywhere you like. You can choose any platform you like. We even allow users to, we offer code that allows users to process the data themselves. So if you're a researcher, for example, and I know a lot of you are, you can actually process the data yourself using code that we provide, using resources that we provide, so that you have full control over the process. So yeah, you have full access to raw data. You can process in any platform. Another aspect is that you see that little light sensor there with the sensor. That is looking up at the sky to measure the irradiant light that's coming in, and that allows you to calibrate the data so that you can compare it over time, and you know that the changes that you're seeing in the data are not due to it being bright one day and then cloudy the next. So radiometrically calibrated, you can analyze the data over time and compare it over time. And that's also a very reliable camera. It's very rugged, very sturdy. It can perform in any kind of environment. And I'll go into more detail about all of these things in just a little bit, but the camera performs well in any type of climate, any type of environment, and manages to keep going. It's also a very easy to use camera. So there are a few things that you do with the sensor here. You're going to basically integrate it into a drone, typically. So we have a number of available integration kits to help you do that for a lot of the popular drones. And we have a lot of partners, a lot of certified resellers and premium partners that offer other integration kits for all different kinds of drones as well, whether you're talking about multi-copters or fixed wings. And also, it's easy to provide power because you can just get power from the drone. It's flexible enough. It has a wide range of power input that allows you to just connect it to a drone to power it. Or you can provide a battery pack, for example, and power it that way. The other aspect of this is that you're going to be flying over field. So you need a way of managing the flight path, and you need a way of triggering the camera. Well, all of that's really easy with RedEdge-M. In fact, there's it gets a number of apps, flight planning apps that support the RedEdge-M. So you can use something like Pix4D Capture, for example, or you could use our own app, Atlas Flight, which we make, and it actually talks to the camera, it communicates with the camera and sets everything up for you in terms of the triggering, so you don't have to worry about setting up any kind of trigger mode or anything like that. However, the camera also has these automatic trigger modes so that no matter what flight planner you're using, it'll capture automatically. So you can capture, a timer mode where it's just capturing every 2 seconds, for example. But it also has this really cool trigger called overlap mode, which actually knows where it is based on GPS, and it knows how much coverage you want. So if you want the pictures to overlap by 75%, for example, the overlap mode knows how far the camera's traveled, and it automatically triggers based on that. So another thing that it offers is after the flight, you can actually see just on the, you connect to the camera via Wi-Fi, and you can see your images that you took, how many there are. You can see the coverage map, how well the coverage was. If it's all green, you're good to go. If you don't see anything, you might realize that, oh, I never turned on triggering or something like that. So you can actually see that you've got the data that you expect before you leave the field. And it's all captured right there on a handy little SD card that can store all the data. And it's easy to just take that SD card out and put it in a computer or something like that and just transfer it right away. So it's a very easy to use sensor. It also produces a ton of valuable information. The kind of information we're talking about here gets at the heart of plant health. So we're looking for changes in plant reflectance. We're looking at how healthy the plants are, how healthy the crops are, where the problem areas are, and finding that out sooner than the naked eye can see. So on the right here, I have a couple of charts. So that little green line that you see there is plant reflectance. So you see on the left side going from 0% to 50%. That's the reflectance, the amount of light that's being reflected back by the plant. And as you can see early on in blue light, there's about 5% of the light or so reflected. And then there's this bump in green light up to about 10%. And that bump in green light is what we see with our eyes. We see leaves that are green. We see plants everywhere that just look green. That's because they're reflecting more green light than anything else. And then you see it's lower with reds and yellows. And then all of a sudden there's this huge slope going up through what we call the red edge band. And then this gigantic amount of reflectance, about 45% reflectance in near infrared. So if we could see near infrared light, plants would be looking very near infrared to us. So that's just a healthy plant. Healthy plant reflectance kind of looks like that. Now, if you think about a stressed plant, there's this bump in reds and yellows like you see in the fall. You see leaves that change their colors that look red and yellowish, and other colors, purplish and things like that. And that's because they're changing the amount of light they reflect in the reds and yellows. That's due to them losing chlorophyll, for example. So you see the differences with your eyes between a stressed plant and a healthy plant. But having a multispectral sensor that can look at all these different wavelengths of light gives you an opportunity to see other symptoms of stress that you cannot see with the naked eye. And so that's what the heart of what we're looking at here is just getting at this stress, getting it earlier on than you can see with the naked eye. And you see I've got two charts there. One is a narrowband camera, which is the RedEdge-M. Now, narrowband means that it's just looking at a very tiny slice of the spectrum at any given time. And you can see there's just 5 points there in the top part that it's looking at. It's looking at blue, green, red, red edge, and near infrared. And the bottom camera is more typical of a broadband camera. Broadband cameras tend to look at a large swath of wavelengths there, so much so that it encompasses more than just one color. So what you call red in a broadband camera actually has some overlap and some band contamination with other bands, sometimes even going as far as to overlap with a lot of the green light. So you're getting some contamination coming in there from multiple bands, and it's averaging out all that whole entire area to get one number for you. So broadband cameras are suffering from a lot of contamination at times, whereas narrowband cameras are very precise. It's kind of like having a higher resolution spectrally. So that's all I'm going to say about that. And if you have questions about that, of course, you can ask me later. But we should probably move on and talk about a few other things here. So with all of that in mind, the RedEdge waveband in particular helps give you a lot more valuable information than you would otherwise have from a typical NDVI camera, because NDVI is just one piece of the puzzle. It's very valuable. It does tell you a lot of good information, but it's primarily focused on the number of leaves that you see, the quantity, basically, the foliage, how robust it is. Whereas NDRE, which is an index that's based off the RedEdge waveband, actually gets to the heart of chlorophyll content. It's much more sensitive to chlorophyll content than the red or the near infrared. So if you see these two examples, on the left you have this NDVI, which is made from red and near infrared wavebands. And then on the right you have NDRE, which is made from the RedEdge and near infrared wavebands. They're telling two different stories here. If you just look at NDVI, you see things look fine. There's no real reason, no real cause to go and investigate anything. Whereas if you look at the NDRE there, suddenly you see some variation. And there's a cause to say, well, what's going on there? Why is that variation there? So now suddenly you have these questions, and you can start to get at the answers. Now, it's not that NDVI is bad. NDVI is just telling you, yeah, there's a lot of foliage there, whereas NDRE is kind of telling you there's a kind of a problem with chlorophyll content in the leaves that are there, in the plants that are there. And in this particular case, it was a misapplication of fertilizer that showed up much later in NDVI, later on in the season when it was too late to do anything about it, whereas the NDRE showed it much, much earlier in the season, where it gave the grower an opportunity to do something about it. So it highlights stress and disease that doesn't really show up in other bands, and it allowed the grower to detect it much, much earlier on and address it in a timely way. So with that in mind, once again, in just one flight with those 5 bands, you're getting a number of different outputs, all from just the one data set that you collect. And it's important to have all these different outputs because they tell you different things about your crop. It's looking at it from many different angles. It's putting all the pieces together to try and figure out what's going on and find answers and find problem areas. So there's so many different possible outputs. You can perform all different kinds of math, and if you're a researcher, you may be available with, you may be familiar with all the available indices out there that have been studied and tried and true. And you may be working on and studying your own. So you're not just limited to NDVI. You can do all these advanced analytics, and a number of these are also available in Pix4Dfields, and they're kind of always adding new ones as well. So all these analysis you can get from this one output, one data set. Now, we talked about earlier how the data is calibrated, and I wanted to go in a little bit more detail about that. So we have 2 ways of calibrating the data. We have a panel, which has a known reflectance. So you see that little white surface there on the calibrated reflectance panel. That little white surface has a known reflectance. For example, we know that it always reflects about 50% light in each band, each of the 5 bands that you're looking at with RedEdge. So if we take a picture of that panel, we know that 50% of the light is being reflected back. So we can do some calculations there. And we're getting the reflectance at the ground level where the plants are. Now, there's another way of doing this as well. So we've got this light sensor there that sits on top of the drone and looks up. And it's measuring the incoming light, whereas the camera is measuring the reflected light. So we're getting this kind of ratio of incoming light to reflected light, and we're doing that for each capture. So if you're flying and then all of a sudden a bunch of clouds come in and they're covering the sky and it suddenly becomes quite overcast, or if it's just generally overcast and the clouds thin a little bit, you can get that change in brightness. You can measure that change in brightness so that each capture has its own calibrated, each capture is calibrated to the light conditions at the time. So calibrating to the lighting conditions at the time gives you a way to compare data over time and know that you're not just looking at a change in brightness of the day. You know that that change in reflectance values is actually due to plant stress, or it's due to just the change in plant reflectance. The plants are actually reflecting a different percentage of light now than they were before. So you can compare season to season, you can compare day to day, you can compare week to week, and you can look and see how that that fertilizer that you applied is doing, or how that prescription you applied is doing over time. You can see, is what I did working? Are the changes I made effective? You can get at all sorts of very useful time analysis and see if your models are working out for you. We talked about how reliable and rugged RedEdge is. I wanted to point out that scientists everywhere rely on RedEdge, and it's been featured in over 65 publications in the past year alone. So scientists are heavily using RedEdge. In fact, they're calling it the standard in the industry for multispectral imaging. And we've got customers all over the world, from Greenland to Australia, using RedEdge everywhere, and we obviously it's been field tested in climates everywhere. It works in temperatures up to 50 degrees Celsius. That's about 122 Fahrenheit. As well as we back the camera with a high level of support. It's made right here in Seattle, Washington, and we build the cameras ourselves. We design the cameras here. We have a local company that builds the cameras, that assembles the cameras, and we test the cameras in our office as well. So there's a high level of support here. There's a high level of pride in these cameras. We're very proud of the RedEdge, and we'll continue to evolve it. And we're just very happy to see it published so much in all the different papers in the science community.
Okay, thank you, Robert, for that introduction to RedEdge. What we're going to do next is I'm going to launch another poll. Should be seeing it on your screen in just a second. This poll is targeted towards your experience level with agricultural drone imaging. The question is, what is your experience level with agricultural drone imaging? You could have some, very little, I don't have a drone yet, or you may be flying with a stock camera, you may be flying quite often and exploring new payloads, or you're already an expert and you're flying with multiple payloads. So I'm just going to give a few more seconds here for everybody to enter your answers. Okay, and I'll be closing the poll shortly. So it looks like most are either somewhat comfortable, still learning, or quite comfortable, flying often and exploring new payloads. So it's great to have you guys here. We'll be kind of with this going into a little bit more detail so that everyone can get some good information based on their background. All right, so for the next section of the presentation, I'm going to turn it over to Jorge with Pix4D so that he can talk to you about Pix4Dfields and what they're doing with their platform. So hold on just one second here. Sorry, experiencing some technical issues. Okay, feel free to take it away, Jorge.
Okay, thank you, Alisa. Yeah, thank you, Robert, for the very nice presentation about the RedEdge sensors. Okay, let me just quickly go into my own presentation. And yeah, let me start saying that yeah, I'm really excited to have the opportunity to talk about what Pix4D has been doing in agriculture for the last few years, and especially the last few months. I'll cover these three main topics, as well as I'll show you, or I'll do a live demo on Pix4Dfields. But I'll talk about what's our vision for agriculture as an industry, what are the fields of applications that we see, and then also what it took to get to Pix4Dfields. So Pix4D started in agriculture already many years ago, spending most of our resources on understanding multispectral mapping, which at the time was a topic that required a lot of R&D, and we were really excited to be one of the very first companies releasing a dedicated radiometrically focused pipeline to deal with this type of data, because indeed these cameras bring in information that require an extra touch to look into the radiometry. But then what we saw very early on was that, okay, once you have that pipeline of processing, the whole product needs to be adapted to what is required in agriculture, which, as you know, is very different from Pix4D traditional market, which was surveying. So we started sort of really rethinking how we approach the industry, and you see on this slide that we are divided in two main spaces. We have what we consider are fields of application. For what now we have a software that delivers results directly in the field, as well as we offer functionality that involves a little bit more of analysis and connection to other farming management platforms. But that differentiation between in-field activities and office analysis, we believe, is quite important. Then one of the things that we've also adapted when it comes to agriculture is the way we address the industry. So you see that we are not going to jump directly into the technicalities of the software, but I always like to mention or talk about the fields of application, because I think this is what is going to connect what we do with what you do with these multispectral cameras. So I always like to start talking about crop protection, where these cameras shine simply because, well, now with our software, you not only can generate results in a matter of minutes, but you have access to a variety of indexes that, as Robert mentioned, they just tell a different story depending on the type of index that you are looking at. So it's very important that everybody understands what's this index for and what am I looking for. And also, in order to enhance this, we offered now a very simple tool, but very powerful, which is a comparison. You can split your screen or look with a side-by-side split view. You can connect what you see on those index maps with what is actually happening in reality, which is very valuable because a lot of the times an index map is not so intuitive. You are looking at something that you cannot see with your naked eye, and sometimes you need a little bit of help to understand what's the actual context. Then we see that obviously crop protection and high resolution index maps are essential for crop protection, but when it comes to crop production, you need to summarize this data in a way that is more manageable for the machines that are doing the variable application, or that the machines that are going to apply the inputs on the field. So that's why we also offer tools that summarize these index maps into zonation maps, as well as we have tools that allow you to very easily and in a very agnostic way, you can make a very simple prescription for your field. And then, as I said before, we understand that our role in the industry is not as a standalone product, but connected with other farming management platforms, so that our outputs are always industry centered. And then there are a couple other use cases or fields of application that I like to bring up, like insurances. So when a farmer needs to prove some sort of claim, as well as erosion and irrigation, which is a topic that it's now both on the educational environment as well as the commercial environment. Everybody needs to understand how to irrigate a field better, so that we use our resources in a more efficient way. And then, well, breeding is a pretty big industry that requires of these very accurate maps in order to get better decisions on the products, whether it's a new chemical that is trying to treat certain disease, or whether it's a company breeding new seeds. This technology now generates a new layer of information that helps take better and more objective decisions. Now, as you saw, we talked a little bit about the fields of application, and now the new flagship that is allowing us to empower the users to do so, it's Pix4Dfields. Pix4Dfields is very new. For those that don't know it, it's a product that was released a month ago, and it's built on these three main pillars. Pillar number one, we want this data to be accurate, as it's always been with Pix4D. We've spent a lot of resources on understanding radiometry, and we want to continue doing so. It has to be instant, meaning that we need to process fast. Just to give you an idea, in the past, Pix4D mapper would generate index maps for a farm that it's 60 to 100. Oh, sorry, I was going to talk in hectares. Let's say that a farm that is about 400 to 500 acres, that would take about 6 to 7 hours. Now we are talking about 2 or 3 minutes, depending on the computer. Also keeping in mind that we don't need any big rig to process the data. Now everything can happen on a normal standard computer. And then also something that we bring across the product is that we want to be agriculture intuitive. We want to talk about the tools and the terminology that the industry uses. So that's also very important for the product overall. And then, yeah, a few of the key inputs or features is, as you already know, we support multispectral cameras, especially cameras like RedEdge that provide so much EXIF information so that we can really take care of that radiometry. Also cameras like Sequoia, and then standard RGB sensors. Everything on the product is built around the concept of field boundary, which for some of you, if you're researchers, might not be so relevant, but in agriculture, an agronomist, a farm manager will 99% of the cases have a field boundary. So we want to organize projects around that. Then for those of you that already know Pix4D and that are used to the pipeline, we are fully compatible with Pix4D software. So if you are still interested in using the big product for photogrammetry, but you want to leverage some of our functionality, that's also possible. And then we have the instant mapping, which is this new technology that we've created where we take high resolution images and we generate maps in instantly, let's say. And then, yes, a variety of vegetation indices that adapt to the needs of the users, as well as this zonation and prescription tool that I mentioned. So now I quickly covered where we come from and what we are doing. But I think that what is more relevant for today is if I do a live demo. So I'm just going to go ahead, close the presentation, and start Pix4D software. So this is what you're going to see when you open it. Very simple dashboard. This is where you're going to be able to see all your projects. We have a couple demo data sets, and then you can open or simply create a new project. For now, we will create a new one. In this case, it's a data set from a farm called Lila. And apparently I already have it, so I'll add a number 2. Then, yeah, you simply create project, and then you have the 2 options to either import the images or import an existing map that you might have. But of course, for the sake of the exercise, I'll process a new project. So here I have all the images from a RedEdge-M, and I'll quickly go open. And now on the left-hand side, I'm going to have a quick sort of feedback on how many images, what's the storage, and when the images were created. Here, I want to make a side note. For those of you that already have a RedEdge sensor, in order for us to process this data correctly, you need to update to the latest firmware. That's what's going to allow us to fully take advantage of the rig and the sensor in order to process as smooth as you're going to see. So yeah, let's go ahead and start processing. So this is now all the images being overlaid on the map. As you can see, the images are simply being displayed and slightly rearranged every couple of blocks. That's because we are doing some partial bundle adjustment while the images are being uploaded or imported into the software. A few interesting things is that these images are full resolution, so we are not downsampling, we are not compromising on that aspect. And then the fact that actually, if you see here on the bottom left, we are now importing the images. And this is actually the more time-consuming task. There's a certain technology bottleneck that doesn't allow us to go faster than this. You will know if you open a big image on your computer, it always takes sometimes a couple seconds if it's quite big. Then, yeah, you see that the map still has artifacts because we wait until the end to make the complete bundle adjustment. And then I'm sure these questions will come up later, but yes, we are doing photogrammetry. This is not stitching. We are simply assuming that the surface it has a rougher DSM than what the Pix4D mapper would traditionally do, because Pix4D is focused on 3D mapping, right? And then, yeah, now we are at the very last stage where the images are being stitched together, and we'll have access to our final map. That, as you can see, it's comparably much faster than in the past. Also keep in mind, I'd like to mention that I'm using the same computer to do the webinar, as well as I'm doing the processing. And I have a MacBook Pro, because yeah, Pix4Dfields runs on Windows and iOS. So that's also a big advantage, just in case some of you are interested in running on Windows. So yeah, here it is. This is the DSM, the ortho mosaic that we've generated. And as you can see, it looks pretty nice. This is a plum plot somewhere in the US. And then I want to show you something, because this is also very new. We have what is considered a very rough DSM that indicates what's the elevation across the field. Just so you know, we are talking about differences of 4 meters, taking into account the trees. So just take into account that this is more of an indication. But okay, so now, as I said, our users really focus around the concept of field boundaries. So we have a very easy way to import them. We'll ask you what kind of layers do you want to trim, so that you get rid of the rest of the data that is not so relevant. So now you see that all the rest of the field is gone. And now, yeah, the first thing that we'll do is generate a number of indices, which now it's available according to the bands that this camera have. In the case of RedEdge, there are 5 bands, so we have access to special indexes like the blue NDVI, which is quite unique. Let's just take a couple for the sake of this exercise, and let's just simply create the index, which, as you see, takes just a couple seconds. And here you can see this is the NDVI, and this is the blue NDVI. And what I like is also what Robert mentioned, that every index tells a different story, and you need to be aware of it. Here is this comparison tool that I mentioned before. That although it does look simple, it helps you understand what's happening. So as you see here, there is more green in between the trees. So this is also present here. And I'm sure some of you are like, "Whoa, Jorge, what are those things that are protected against the tree?" Those are the shadows, and we know this is an issue because this does not provide any relevant information. But actually, we are working on an enhanced vegetation detection algorithm that will simply get rid of it and then just show you what is relevant, which in this case is the vegetation. Then, yeah, very quickly, I'd also like to show you that there is an annotation tool where, you know, we can see here, in some cases, for example, the fact that there is more grass in between the trees could be a leak. So we can add a very simple annotation for the people on the ground to go and see what's going on. And now I like to actually show you another tool, which is the Zonation. But for this, I'm gonna jump into another data set because I don't want to say something that is completely irrelevant in the case of a high-value probe like this. Because when we talk about Zonation, this is something that is more relevant when it comes to a classic commodity crop. So let me just open this other data set that I have here that Robert will tell you a little bit more later on. It just takes 1 second. So here it is. I'm opening it right now. In this case, it's quite a large farm. I don't remember the number off the top of my head, but it was much larger than the one that we processed, and it only took about 10 minutes. Here we have the blue NDVI and the NDVI again, which look very similar. But the interesting part here is that, well, actually, I always like to show this because it looks like an artifact, and maybe some people thought so. But if you do a comparison with the orthomosaic, this is actually some issue that the planter had on that area. So this is the classic example where you could use this to prove to the insurance company that there was something going on there. But okay, let's zoom out again, and I'll show you the tool that I wanted to demo, which is the Zonation. Very easily, you just select the map that you want to use to base your zonation. You select the level of detail, and you select the number of classes, let's say 5. And very quickly, what it's going to do is just the classic vector tool that converts a raster into a vector, which in the context of agriculture is just creating zones that are more relevant when it comes to applying different amounts of fertilizer or taking into account different treatments. Please don't pay too much attention to the colors, because that's just an indication, and they are not necessarily too correlated with the NDVI scheme. And here, what I wanted to show is that you can already see that if a traditional farmer says, well, I've been applying 150 kilograms of nitrogen per hectare for every region, and this is what I'm going to continue doing, so he can already see that, well, he's going to spend quite some an amount of nitrogen. It's going to be about the 10,000 kilograms. If you already acknowledge that the areas that are in red are not necessary, and these areas, well, you don't want to spend too much money because you're probably not going to get as much yield as you like, but then on the areas where you know you can improve, you still apply quite some fertilizer, as well as you reduce it where you don't, you see that there is directly a saving on almost 40% on the amount of nitrogen that you're going to apply. This is not groundbreaking. Everybody that is doing digital agriculture that has some sort of variable rate system is doing it today. But this tool sort of helps communicate what's the purpose of it. And then, yeah, you simply click apply, and this becomes just one more layer that we are going to use, and you're going to be able to compare with your orthomosaic or your blue NDVI, etc. In this case, for example, I believe this farm was the user was looking for tiling, and the index maps already, but more especially the orthomosaic are really highlighting that. And yeah, then the one last thing is that you can export all this information, obviously. So as I said, you simply select the layers that you want to export, and then you can select the different types of formats. And then, yeah, you have all the standard raster files that will be only exported as a GeoTIFF. And then, yes, you simply click export, and then you select the target folder where you want it, and here we go. You just create a file which is ready to take into your farming management platform of choice. And that's normally the story that we tell. But then in the case of researchers, you can then take this into QGIS and do some further analysis. Okay, so that's it for me. I'm gonna give back the rights to Alisa. There you go. And then I'm sure you guys have some questions about, hey Jorge, how about the calibration target? You haven't talked about it. We really like calibration targets. I think this is something that we will address a little bit later on, and I'm happy to give you guys some visibility on what's coming. Thank you.
Great. Thank you, Jorge. So for the next, to kind of conclude here, we're going to ask a last poll question, and then Robert will go into a little bit more detail over the user experience that Jorge kind of mentioned with soybeans. So let me just launch the next poll. This one more has to do with what problems you are trying to solve with agricultural drone imaging. Could be identifying crop stress, counting individual plants or trees, yield estimates, a section of the above. Generally, we see that most people are doing a host of all of these. So this kind of just helps us understand where to put some product development time. Okay, great. Thank you so much for answering. I'm going to close the poll now in just a second. Okay. And the results. So it looks like, kind of as we've seen before, most people are doing majority of all of those things. Identifying crop stress, identifying and monitoring disease seems to be the most popular, but most people are doing, as we expected, all of the above. So that's great. Thank you so much for participating. Okay. Now, like I mentioned before, we're going to go through the last section of the presentation, which is the user experience and the problem solved with RedEdge and Pix4Dfields. So Robert, if you'd like to go ahead and start.
Thank you very much, Alyssa. So we have Adam Bachelet from Heartwood Labs. He sent us this data, the soybean data that you saw, and the story there is that this is a service provider who flew over 160 acres of soybeans, and their goal for this was to locate the drainage tiles. And as you can see, you know, we use Pix4Dfields there to get at a number of different ways of looking at this field. But their goal there was to look at drainage tiles. The details of this were that they used a RedEdge-M. They were flying with a DJI Matrice 100. They flew at about 400 feet with about 75% overlap, and it took about 8 minutes to stitch with Pix4Dfields. Next slide. And what they told us was that they used to process with Pix4D Mapper, and that took about 4 to 6 hours of computing. So I'll just read the quote here. Before Pix4Dfields, processing alone could account for 4 to 6 hours of computing and office work. Now in less than 10 minutes, we have our maps and indices. This means we can deliver finished products to customers on the same day. So that's a pretty significant impact there that Pix4D has made. It's amazing to see how it can go from just all of these, you know, hundreds to thousands of files, because, you know, you're getting 5 images with each capture you take, and you're overlapping by 75%. You're flying, and you're getting a ton of data there. It's amazing to see how Pix4Dfields can just take all of that data and process it so quickly, and then give you analytics. It goes from data to answers really, really fast, and we find that to be kind of amazing. So in the end, let's just sum it up here. What problems does Pix4Dfields solve for RedEdge users? Well, we're very excited about this. As you can see, it's a very easy application to use. It just flattens the learning curve. There's not a lot of knobs and switches to tweak and stuff like that. You're just getting right to the heart of it. You're saying, okay, this is the imagery I want to process, and I need it processed right away, and then bam, you get your answers. You want to have your analytics in the same application. That's easy as well. The learning curve's been flattened there. As far as computer resources, as Jorge said, he was just using his laptop there to process this. So you're reducing a lot of the required resources there, and you're getting rid of that processing bottleneck, essentially, by being able to process so quickly. It's no longer something that needs to be a consideration. And by having the analytics and processing in the same platform, you're getting to answers really fast, and that's something that I really love.
Great, thank you so much, Robert. So the next section is our audience Q&A section. I've been seeing a bunch of questions come in through the question section. So we're going to pick a few and go through all of them. We probably won't be able to go through every single question. So what we'll be doing is following up afterwards with answers to each questions in the follow-up email. So look for that. But we're going to pick a few, and Robert and Jorge, I'll cue you as to who the question is for. Okay, so we've got one question from Nigel Cook. This is for Robert. Does the light sensor take into account the angle of the drone?
So that's a good question. And so yes, all of the angles and stuff are measured. So there's a magnometer that provides data to each image. So every time you make a capture, there's a magnometer in there in the GPS that tells us what angle and heading the camera is in and stuff like that. So a little bit of that is taken into account. And as we improve our hardware, we're looking at other ways to take angles into account, and we'll have more on that in the future, I'm sure. But we're continually looking to improve the it is helpful to know where the sun is and to account for angles and stuff like that. So it's a good question. We do a little bit of that right now. We're hoping to do that more in the future.
Great, thank you, Robert. For Jorge, is there going to be crop counting implemented in Pix4Dfields in the future?
Yeah, so that's a question that we get a lot, and for that, in Pix4D Berlin, we've got a team of machine learning experts that are working on the problem, and we already have some exciting results that we hope we will be able to push to the software really soon. The reason why it always takes a little bit longer is because when it comes to machine learning, we want to make sure that we are not just overfitting a problem, but really create a tool that solves, most of the problems. So when it comes to plant counting, you need to train your algorithms with a lot of data, and you also need to enable training. So there is a pipeline where the user could actively select whether a plant is not a plant or why it's not a plant. So reduce the amount of false positives and false negatives. But this will be coming. We are working on it.
Great, thank you. For Robert, this is a question from Drew Johnston. What is the resolution of the RGB camera sensor? What settings can you change on it? How high do you usually fly to get accurate reflectance maps with RedEdge?
Okay, a lot of questions there. So the resolution of RGB, so RG and B are just 3 bands of the 5 bands. They're all the same resolution. I actually, off the top of my head, I can't think of the resolution. I think it's something like 3. What's that?
I think it's 8 centimeters per pixel, right?
Sure, 8 centimeters. If you're talking about ground resolution, yes, that's the resolution. I was trying to think of megapixels, but yes, if you're flying typically at 400 feet, which is what we recommend, then you're going to get 8 centimeter resolution per pixel. So that just means 1 pixel represents 8 centimeters on the ground. But of course, you can fly lower. You could fly 200 meters, for example, and you'd get 4 centimeters. So, you can fly at any altitude you like. Usually we recommend flying higher, incidentally, as it may sound counterintuitive. Like you may think, oh, I really want, really high resolution. But actually you're getting a really high, 8 centimeters per pixel is actually a very high resolution itself. And when you're generating these indices, to have this kind of higher level view. Let's see, what were some of the other questions in there? I think I covered them all. I'm not sure.
I think you did.
Okay.
Yeah, I think you did. Jorge, question for you. Is it reliable to generate zonation maps based only on vegetation index? Do you have any examples of this? From Juan Pablo Gutierrez.
Okay, I always say, oh, that's a great question, but that's a question that we asked ourselves internally. You can generate zonation based on many different layers, not only remote sensing or index maps. You can make a zonation map out of a soil map. You can make a zonation map out of the yield data. So there are many different sources. We are just adding one more, right? And in this case, well, a lot of the plant features are related with the soil, and that's being captured by the index map, and then the zonation is capturing that. What we typically recommend is that if you're doing serious zonation, first you might want to correlate that with the DSM, which is something that we also want to do, but it's not right now available. So there are many farming management platforms that do so, and then you want to be able to maybe also use the soil maps to generate what is going to be a more comprehensive zonation map. But from what we've seen and from the feedback that we've got from the agronomists and the farmers that we've worked with, the zonation map, it gets really close to reality. and we are constantly working on improving. So now you've also seen that there is a basic DSM layer that gives you a rough estimate on how the ground is looking like. So that will also be taken into account, and we will constantly improve it. But as far as the feedback, the answer is yes. These zonation maps correlate quite well to existing zonation maps.
Great, thank you. Another question for Jorge. With Pix4Dfields, what are the cloud sharing options to share with farmer clients? It's from Laura Thompson.
Yeah, so we are working on that because, well, right now out of Pix4D, you can easily just generate the exports and share them just like a normal file. But then for every Pix4Dfields license, you have the access to Pix4Dfields Cloud. And through that, you can also share the orthomosaic, the DSM, and the NDVI map. But right now, this is not as smooth as we would like it to be, because we aim for a complete smooth transition from desktop to cloud, where all your layers will be available. And when that happens, you will simply need to copy the URL and then share it with whoever you need so that they have access to the data. We are working towards more integrations. So, for example, Atlas is another platform that we want to support. We just need to tweak a few things. There are other farming management platforms that we want to connect, like Climate Core, Field View, My John Deere. There are a number of platforms that we are targeting at the moment, but the product is quite young, and we are still building up a lot of that functionality.
Great, thank you. Robert, a question for you. The RGB image that I can get from the discrete R, G, and B bands in the RedEdge-M, how different is it visually from a standard camera, where it seems to be that the bands are overlapping?
So the RG and B that you get from RedEdge-M should not be too much different at all from a standard camera. The standard camera might be able to give you a much higher resolution. I mean, they're packed, you know, you can get a camera with like 20 megapixels or more, whereas the RedEdge image is about 1.3 megapixels. So it's going to be a higher resolution at the same altitude. But other than that, I mean, it's looking at very targeted RG and B wavelengths, and it should be about the same as you would get from a standard camera.
Great.
If I can complete on that, I think also a lot of the times people are, well, but on an RGB sensor, on a standard RGB sensor, all the images are stacked on top of each other because there is just one sensor. On RedEdge, you have 3 different sensors, so there's going to be a slight misalignment. That's where the information that RedEdge gives to Pix4D is used. So we take it into account as a rig, so that all the images are perfectly aligned.
Perfect. Okay, we've been seeing kind of this question come up a few times from a few different people. Jorge, perhaps you can talk about the calibrated data and calibration panel aspects of using Pix4Dfields with RedEdge.
Yes, so this is a question that has been coming up a lot, and as of today, on Pix4Dfields engine is not taking into account the information from the calibration target. The reason why is we were working towards a sensor that doesn't need this calibration target anymore, because the information coming from the irradiance sensor can be used to generate absolute reflectance values. But after the release, we came to the conclusion that there is many people, especially on research environments, where they still want to use the calibration target. So as of right now, the team, the algorithms team is working on bringing in the libraries that we have today on Pix4D Mapper, so that when you import calibration images, those are taken into account as well for the processing.
Great. Robert, this question is also coming up a lot. Can you talk about the difference between the MicaSense RedEdge and the Parrot Sequoia?
Sure. Both are products that we sell on our website and we offer. One is made by Parrot, a company in France. A lot of people confuse that we make the Parrot Sequoia in Seattle as well, but we don't make the Sequoia. The Parrot Sequoia is actually made by a company called Parrot in France. Obviously, the MicaSense RedEdge is the one that we make right here in Seattle, Washington. A few of the differences are, well, if you look at the multispectral bands on the Sequoia, you'll see there's only 4. So they're missing the blue band essentially. And that makes a big difference actually when you're looking to align all the multispectral bands together. Yes, they do have that RGB camera on there, but it is a rolling shutter and it's not really useful when you're trying to combine data from a drone. And it's got the rolling shutter artifacts. So when you're looking at just the multispectral bands and you're missing that blue band, you're not going to get that RGB scouting image. Sure, you can kind of create a fake one and put together fake composites and stuff like that. But you can't really get to other things like bloom density and things like that. And we've written a whole blog article about the importance of the blue band. And in fact, our blog is at blog.micasense.com, and you can check out that article and some others. Other differences would be in terms of hardware and robustness. We see a lot of problems with the Sequoia in hotter climates, and it just can't withstand a lot of the higher temperatures. Whereas we talked about earlier, the RedEdge is definitely capable of supporting those higher temperatures. There's some other differences as well. We have a comparison chart on our website that you can check out. So I'd highly recommend visiting micasense.com and as well as blog.micasense.com to see some other differences.
Great, thank you. So at this point, I think we're going to close the webinar. It's been great to have you all. We have a ton of questions that have come in, so we'll be answering those, as I said, in the follow-up email. You can join our mailing list for both Pix4Dfields and MicaSense RedEdge. There will be links in the follow-up email to do so, and we'll also be sending a copy of the slides and the recording and posting both those on our websites. So stay in touch, and thank you very much for joining us, and we'll see you all back soon.
Yep, thank you very much, everybody.
Thanks, everybody.
Bye.